Hi, welcome to the assignment number 7, problem number 3. So the problem is given linked list, write a function to reverse every k nodes where k is an input to the function. If a linked list is given as 1, 2, 3, 4, 5, 6, 7, the output should be 3, 2, 1, 6, 5, 4, 8, 7 for the k is equal to 3 element. So the problem is here is what we have to do is we have to divide the given linked list to the kth element, and then we have to reverse each group of the kth group of the elements and reverse it and make it as a single linked list. Let's see how to implement this problem. So the output should be 3, 2, 1, 6, 5, 4 and 8, 7. What we are going to do here is first we are going to explain how to reverse the single linked list by using the reverse function here what we have written. Here for the reversing we are going to take nodes P and Q, and we're going to take head as a parameter. For example, if P is a parameter here, 1, 2, 3 are the single linked list. By using this code, what we do means we take P and Q pointers. P is equal to starting point and Q is equal to the P next. That means here we're going to use the recursive function, and we'll check whether Q is not equal to none. Then it comes and it comes here, and then it'll execute it again. So what will happen here means P will become P next, then come to here and it returns Q. It is going to make like groups, like first function it is going to make this group, and second it is going to make this group, and third it is going to make this null. So what will happen here? So P will becomes P's next, that means this, and it will comes here and it will be here, then it return Q. So this is how we are going to, by the end of the function we are going to get 3, 2, 1 by using this function. So let's see how to implement this problem by using this function, reverse function. What we're going to do here is we're going to take one swag groups function and node start and int kth value as parameters. Node starting point is here, and we're going to take pointers P and Q and new start and temporary nodes. So for this loop what we're going to do is first P has to traverse from starting point to the kth value and make a group. By using this while loop it is going to make this. If P's next is equal to null, it will just return and break the out of the loop and come out until the count is equal to 3. Then it will come after 2. By that time P will become P's next every time. Now P is here and it is a new start. So then Q also be here. Q is also new start. New start become P and Q is also new start. The both positions are here. Then it will enter into this loop while of 1 it is true and P is equal to start. P will become starting node, and temporary by making group of this we have to reverse them. So P is going to be the starting, then the link will be broken, and we have to save this address of this next element in the temporary variable. Here we see Q's next is equal to temporary variable. So if temporary variable is equal to null, then it will just reverse, and we will see this part later. It will come here, this part will come here, and it will check q's next is equal to null. It will make q next is equal to null and start is equal to temp. Then this will become the temporary variable, and by that time this uh, group of elements will be reversed. So again it comes here while loop. It will make the part of the kth value by using this code while k is equal to until k is equal to count. It will traverse from p from here to here. Then after this p next is equal to q. That means it will reverse. If p next is equal to null, temp next is equal to null, then it will reverse this group, and it comes here, and the next part will be this one, and the same procedure will be happen again. So this is my approach here. The time complexity is order of n for this while loop and order of n square, because there is a while loop, there is one more while loop, plus order of n recursive by using this recursive order of n. So 2n plus n square is the time complexity for this solution. Thank you.